Okay, this lesson is about the solubility of salt, and solubility of salt. The salt that I meant in here is the salt that do not dissolve in water very well. For example, like calcium carbonate, and then usually these insoluble salts are formed from a reaction called a precipitation reaction. Like calcium carbonate here is formed from the reaction between calcium chloride and and sodium carbonate, and it produces sodium chloride, which dissolves in water, but calcium carbonate doesn't. So now when I talk about the insoluble salt, in actuality, that this salt that we say that do not dissolve in water, in actuality that they do dissolve in water a little bit, but it's not uh, visible by naked eyes. Okay, for example, if you have something like silver bromide here, silver bromide, if you put in pure water, a tiny amount of, sorry, this is silver bromide. The tiny amount of silver bromide will dissolve and it produces silver ion and bromide ion. Okay, but it's so tiny. Look at this. The concentration from the experiment, the concentration of these two, it is found to be 7.35 times 10 to negative 7, which is very, very small. You can't see it by naked eye. That's why we say the silver bromide do not dissolve in water, but in actuality, they do. So now, what happened? How do what can we do with this number? So now if you see this equation, okay, and then you know that if you leave silver bromide in the water for a while, some of it will dissolve, some of it will precipitate back. You will have this equilibrium that will be established between the solid and the ions. And then once this equilibrium is established, the concentration of the ions will remain constant. Okay, in this case, it is found that the concentration of the ions are equal to 7.35 times 10 to negative 7. So now, based on this chemical equilibrium, so if you want to write the chemical equilibrium expression, you will have the product of two ions, okay, and divide by the concentration of the reactant, but the reactant is solid, so it does not show up in the chemical equilibrium expression. So literally, the KSP, so solubility product constant, will be equal to the concentration of the two ions multiplied. And then when you plug in the values, you multiply them, you will have something called a KSP. And this will be constant. Okay, and it will be constant at um, at particular temperature. Usually, if we don't say what temperature it is, we always make assumption that the temperature is at 25 degrees Celsius. Okay. All right. Let's move on to next slide. Next slide. Okay. So this slide is basically over here is showing you the general term for how to write the KSP. So for example, if you have this insoluble salt, okay, A is the cation, B is the anion, and split into the cation and anion. So the KSP is usually the concentration is usually equal to the concentration of the cation, okay, to the power of the coefficient, and then multiply by the concentration of the anion power to the coefficient. For example, if you have silver sulfate, okay, so silver, there's two over here. So when it dissolves into the water, produce two silver cation and one sulfate anion. So when you write the KSP will be equal to the concentration of silver, okay, to the power of 2 to square, and then multiply by the concentration of sulfate, okay, and then to the power of 1 because the coefficient here is 1. And it is found at 25 degrees Celsius, the KSP of silver sulfate is equal to 1.2 times 10 to the negative 5. Another example is calcium fluoride. This will give you one calcium cation and two fluoride ion. And then you write a KSP, it is going to be the concentration of calcium ion multiplied by the concentration of fluoride ion to the power of 2 because the coefficient is 2 over here. And at 25 degrees Celsius, the KSP calcium fluoride is equal to 5.3 times 10 to the negative 11. Okay, so now usually students get confused between the solubility product constant, the KSP, and the solubility of the compound itself. Now, we want to make sure that you understand the difference between these two. When you talk about solubility of salt, basically we're talking about how much that salt dissolves. And then the unit, there's a unit for the solubility. The unit can either be molarity, mole per liter, or grams per liter. Now, on the other hand, when you talk a little bit about the solubility product constant, this is the KSP itself. It is an equilibrium constant. It doesn't have a unit. Okay. Let's go on to next page. Now we want to make the connection between the KSP and the solubility. So, okay, if you have calcium fluoride and you dissolve in water, okay, and then it will dissolve a little bit, okay, to produce calcium cation and 2 fluoride ion. This problem is asking you to calculate for the KSP of calcium fluoride. So now let's try. So let's write the chemical equilibrium expression. The KSP is equal to concentration of the calcium ion multiplied by the concentration of the fluoride ion square. So we know that the concentration of calcium ion is equal to 2.3 times 10 to the -4, and then the concentration fluoride has to be double that because 2 over here. So 2 multiplied by 2.3 times 10 to the -4. So what you have is 4.6 times 10 to the -4 molar. Okay, so plug in the value. The KSP will be equal to 2.3 times 10 to the -4 multiplied by 4.6 times 10 to the -4 square. And then this will give you the KSP that is equal to 4.9 times 10 to the -11. And it doesn't have a unit. So that's it. That's how you find the KSP. Okay, so I'm gonna stop this video right here, and then we're gonna have another one after this to talk about 2 more problems, okay?